Well, so now it's 3 o'clock. So shall we get going? um, so I guess why don't I turn it over to you, Julie, and you can take it from here.
Okay, so now we're turning to our graduate portion of the ceremony. So I'm Julie Bergner, I'm the Director of Graduate Studies, which is why this part's being turned over to me. So I would like to start, we'd like to honor 2 of our graduate students who've received teaching awards this year. And the first is the Outstanding Mathematics Graduate Teaching Assistant Award, which is awarded every year to among the grad students in the department for their excellence in teaching. And so this year, the awardee is Andrew Coben. So Andrew, do you have your video on? Can you?
Yeah, I'm here.
Show yourself. Okay, there, yeah, there's Andrew. So please, a round of virtual applause for Andrew. And and then our second one, we are very lucky this year. We've got one of our students who won not just a math department award, but one of the all university graduate teaching awards. And that is going to Shiroshi Maitra. Shiroshi, do you want to turn your video on as well so we can see you? Congratulations.
Thank you, everybody. Thank you.
Virtual applause to both of them. It was very well deserved. Okay, so now, so moving on, we have 5 students that we'd like to honor who are receiving master's degrees. And so as usual, after I read off each of their names, you can respond with whatever virtual applause you prefer. So these people are Vishal Bajaj, Rebecca Claxton, Nicholas Collins, Bennett Renier, and Morrison Chernansky. Congratulate all of them. And so lastly, then we also have 5 students that we are honoring that are finishing up their PhDs this year. And so we'd like not only to read their names, but we've asked their advisors to say a few words just about the students and what they've done. So my first question, Andrew Obis, are you here? Because I'm not sure that he is. Okay, I'm gonna skip his students momentarily in the hopes that he shows up. So I'll move on then so I'm gonna skip the first 2 people on the list for a moment in hopes that their advisor shows up. And so the next student is Alexander Morgan, whose advisor is Andre Rapinchuk. So Andre, do you wanna say anything? You have to unmute your, we can unmute you, I guess. I'll unmute you.
I'm wondering if Alexander is joining us or.
I don't know. Alexander, are you here?
Maybe not, so I can still say a few words.
Please
First
do.
of all, congratulations to everyone. And then specifically about Alexander. Well, there were some unusual features in our collaboration with Alexander. So usually the joint work between the advisor and the student lasts like 3, 4, maybe 5 years. I have known Alexander for more than 15 years. He was actually in my first class, honors calculus class that I started offering it. So he went through our undergraduate program. He also got master's, and then he joined the graduate program. Mm-hmm. And during his time at the graduate program, he did not just one dissertation, but I would say at least 1.5 dissertations. The way this happened was the following. When he joined the program, I gave him one problem on the explicit version of the strong approximation theorem, and we made some progress. But then some health issues got in the way, and he had to take a leave of absence for a year. And when he came back, that problem was already solved by a quite distinguished guy who is a professor at Cambridge now. So I had to give him something new. And well, he managed to find the proof that people have been looking for since at least, late 70s or early 80s. I don't want to take too much of your time explaining what this problem was about, but this paper was published in Algebra and Number Theory, which is a pretty good journal. And there is also some follow-up work on Alexander's work. Anyway, I'm happy that this day has come, and he is receiving his well-deserved degree. So congratulations to him and to everyone else.
Great, thank you, Andre. Okay, we now have Andrew here. So I'm gonna go back and so our next PhD recipient is Hui Dong, and I'm gonna turn it over to Andrew Ovis, his advisor, to introduce him.
All right, hi everybody. So glad to be able to join everybody virtually here. So I'm talking about Hui Dong, who's been my student now for, I guess, about 5 years or so at UVA. So he has written a very nice thesis and has done quite a bit of work that's not in the thesis also. So he's been studying kind of deformations of curves in characteristic P. So kind of the way that you can stretch a Riemann surface is not the same as the ways that you can kind of bend and stretch a curve, defined as by an equation of two variables in characteristic P. And the first question that I gave him was to show that, that there were some examples of these deformations. And I said, show that there's nothing else. Show that these are the only kind. And it turns out that they're not the only kind. And he found, a month or two after I gave him this question, that there were these really kind of crazy examples that I would have never thought of. So I was really, really impressed when he was able to do that. And since then, he wrote that up in a paper that's appeared in the Journal of Algebra, and he has, a couple of follow-ups from that, and is now working, among other things, on a conjecture called the refined local lifting problem, which is a big generalization of, a theorem that I proved back in 2014. So it's very interesting work, and not sure exactly what's happening, but he has an offer in Nanjing, China, at one of the Yao institutes at the Southeast Center, and depending on the state of global travel, hopefully we'll see whether that is in person or remote. But I'm very proud of him, and really wrote a great thesis, and congratulations to Hui.
Thank you, Andrew, and congratulations. All right, I'm going to turn it back over to Andrew because our next PhD recipient is also a student of his, and that is Andrew Coben.
Okay, I didn't realize that the alphabetical order was going to be 2 in a row. Okay, excellent. So Andrew Coben and I have also been working together for, I guess, about 4 years at this point. And he's had, of my students, I think we only actually had 1 year together at UVA in person. So he has been very independent and really. So his main thesis project that we started working on, talking about together. So there's something called algebraic variety, which maybe most people know, which is just you take some algebraic equations and you look at their zero locus, and that's a variety. And then there's a generalization of this called a scheme, which maybe not everybody knows, but maybe a lot of people know, but that's fairly classical from Grothendieck from the 1960s, which kind of unifies a lot of algebraic geometry and number theory. And then there's something more general than that called a stack, which is a better construct for dealing with moduli problems. And so it turns out that there's something called a tame stacky curve, which has been written about quite a bit recently by papers of John Voigt and Dave Zurich Brown. And this has to deal with looking. It's kind of the algebraic geometry analog of an orbifold. So you take a curve and you hit it by some automorphisms, and there are some fixed points, and this thing kind of remembers the fixed points, that they look a little bit weird. So what Koban has done, which is really great, is come up with this theory of what's called an Artin-Schreier root stack, which is, again, if you notice a general theme here, what happens in characteristic P when there are these weird automorphisms and crazy curves. And so Andrew has basically, you know, written down kind of the complete theory of what happens when you have a group of order P acting on a curve of order P. So, you know, it's a really great piece of work. It's under submission now. And I should say that on top of this, Andrew has just been involved in all these sorts of projects that I've had nothing to do with. And this is the consequence of having me only around for a year. So he has a collaboration on formulas about, you know, intersection numbers and degrees with another graduate student at Stanford that I had absolutely nothing to do with. He's generalizing our work to further higher groups of P power order instead of just characteristic P. Apparently he has something going on with Julie Bergner now with homotopy theory. And so he is, you know, completely a mathematical citizen of the world, and with his feet in many pots. And I think he's going to do a lot of wonderful things. And he is going to UC Santa Cruz next year, either virtually or physically, to start as a visiting assistant professor. And he's really done fantastic work. So congratulations to Andrew.
Congratulations, Andrew, from Aunt Gail and Uncle Mark.
Okay, great. Thank you again, Andrew, and congratulations, Andrew. So our next student is Thomas Wirt-Sale IV, and at this point, I'm going to turn this over to Wei-Chung Wang, his advisor.
Hi, everyone. So yeah, Thomas has worked with me for 4 years. When he first started coming to my office saying, okay, I'm interested in working with you, and something like that. He didn't take my class before, so that took me a little bit surprise. And I said, okay, all my students need to know this basic thing about the algebra and symmetry group. He said he took the algebra class, symmetry group. I said, okay, this book, I can, it's a very nice book by Bruce Sagan. You can read it. Then the next week we meet again. He said, yeah, I read the book. I said, okay, well, good, you started reading it. Which chapter? He said, I read the book. Well, the whole book, which is probably 300 pages, something. It's well written, but still I then try to test him a little bit. He probably get 80–90% out of it, as far as I could tell. Another week, I think he was really good in that subject. That's how we started. And basically, Thomas has been very much a proactive, self-resourceful. Every week he comes back, basically tell me the new computation, and he's always optimistic about this, what can be done. So let me turn to the subject he has been working on. The title of his thesis is Quantum Symmetry Pairs and the Quantum Supergroups at roots of 1. Let me just mainly emphasize the quantum symmetry pair part. Out of this thesis, he has written so far 3 papers. One paper was not included as a thesis. They were, which was published by Journal of Algebra. Then there's a second paper published by Latin Math Physics. Another one I heard just got accepted, tentatively accepted by Advance. And there are 2 more chapters in his thesis, which is has not been published, basically. And so this quantum symmetry pair is in the subject direction of quantum groups. And quantum group was invented by Granville and Jimbo in the 1985–86. In spite of the name, quantum groups are not groups, they are algebra. And well, they are related to the usual Lie group and algebraic group and so on in many different way, closed way. And they in particular have certain integral structure, you can define over integer, which allow you to do the base change to the roots of unity. That's what Lucic did around 1990. And that turned out to be extremely powerful and make this connection to algebraic group at catalytic P. Turns out quantum group at the roots of unity is a very good approximation of algebraic group in catalytic P. Our colleagues, Pasha and Scott, they spend much of their career working on this type of direction. So it's a very active direction. The part of the title quantum symmetry pair was introduced by Gail Lester in around 1999. It's not that old, about 20 years earlier. She was introduced this class of algebra, which was a faster generalization of quantum groups. Her original purpose was to do certain harmonic analysis on quantum symmetric space. But about 5 years ago, really it started in the thesis of Huang Chenbao, 2015 at UVA. We realized this much more in this class of algebra, which make it really the genuine generalization of quantum group. Quantum group has been active in Lagrangian theory for 35 years. We essentially realized probably everything done in the last 35 years in quantum group should be generalized to quantum symmetric pair. And so there's a lot of work which can be done and lots of theses which can be written in this direction. And there have been a couple theses written in this direction. So Thomas' thesis is one of those. He basically used the integral structure of this quantum symmetric pair, which nowadays I also call it I-quantum groups. They are generalization of quantum groups. And then because they have integral structure, you can do roots of unity by base change. And he generalized some fundamental theorem of Lucic. Lucic defined a notion of Frobenius Lucic homomorphism, which generalized the Frobenius homomorphism from catalytic P to quantum group at roots of unity. And turns out, Thomas shows this can also be done for these I-quantum groups. And this motivate and allow us to introduce a new class of algebra called the small I-quantum group. That is a generalization of Lucic small quantum group. And small quantum group has hundreds of papers follow, and this is a fairly active research direction with connection to the geometry of flag variety, affine Grassmannian, and some cohomology computation related to the nilpotent orbit, and so on. So Thomas' paper is basically the first paper on this I-quantum group at the roots of unity. I do hope there will be much follow-up of this research direction. So his own chapter has 2 more chapters in these directions, which I'm sure will at some point turn into papers as well. So Thomas has done a really fantastic job in his research. He also, working with him make the job of being an advisor extremely easy. He just go home every week, give you something new. Then pretty much, then these things, the question is natural, then he's always, you just say, go home compute. He just compute, push things to various limit, and certain things I certainly never even thought about it. And so it was really nice to work with Thomas. Congratulations, Thomas. Yeah, thank you.
Thank you, Wei Cheng, and congratulations, Thomas. And then our last PhD recipient is Mark Allen Schreckengast, and he will be introduced by his advisor, Peter Abramenko.
So I guess you should all hear me. So now I'm unmuted. So I met Mark for the first time in the summer of 2015, where he was preparing together with a lot of other students for the algebra general exam. And then after his first year, he immediately started in a group with a couple of other graduate students to participate in an informal seminar on Kac-Moody groups and also Kac-Moody Lie algebras, which I organized and which run for quite a time. And he was interested in working with me, and then he first did some work about Coxeter groups and also produced a paper in that context. And then I think in 2018, he started seriously to work on a pretty ambitious PhD project. The title of his thesis is Finite Generation of RGD Systems with Exceptional Links. I mean, as usual with mathematical papers, if you are not an expert in the area, there are a lot of terms which you don't know, even as a mathematician. So I'll try to give you some rough ideas what's going on and what the problem was, what Mark then very satisfactorily solved. There is a big class of groups which allow additional structures due to what is called a BN pair or a twin BN pair, or also RGD system. So typically you get these additional structures if you in the classical case you consider certain matrix groups like GLN, SLN, or the orthogonal group over a field, and then you get what you call a spherical BN pair. If the field in addition has a valuation, then you can also get an affine building or Breuer-Titz building. And then in the 80s, a new, or maybe it started earlier in the 70s, development of so-called Kac-Moody algebras and related to them Kac-Moody groups. And then it was Titz who again associated an important additional structure to these groups over fields, which he called RGD systems. And there are different kinds of groups which satisfy corresponding axioms. And there was, for instance, maybe 10 years ago or so, a big paper in the Annals about one class of groups, so-called S-arithmetic groups, and their finiteness properties. And one of the interesting thing was that even though the method of proof had to be changed for small base fields, there were no exceptions. And what I gave Mark as a project for his thesis, if all of these S-arithmetic groups act on buildings of affine type, so the apartments are tessellated Euclidean spaces. And I imagined that for the simplest case of finiteness properties already, namely finite generation, you would get certain exceptions over very small fields, base fields, if you had hyperbolic types. And so Mark investigated these groups of where the corresponding Coxeter groups are of hyperbolic types over small fields F2 and F3. And it was a subtle interplay of combinatorial group theory and also geometry. So one nice aspect of his whole thesis was that he also had to use geometric intuition, namely he had to use geometric models of these hyperbolic Coxeter complexes, which are hyperbolic planes tessellated by triangles. And he also did, in addition to the mathematics and very non-trivial and nice proofs, he also created some very nice, accurate pictures. And what has never happened with the thesis, which I was advising, there was even a program, some code involved. And so the last part of Mark's thesis is an appendix on the code for diagram generation. And that was really nice to see how the geometric ideas could really be shown in his thesis with his pictures. And so at the beginning, I had just one counterexample for a special diagram over F2 in mind. And the final result of his thesis is a complete classification for certain rank 3 diagrams. And these are the exceptional links in his title, which can only occur for the base fields F2 and F3. And he could decide in each single case whether the corresponding group there is finitely generated or not. So that was a very nice thesis, and I'm happy that Mark could give such a complete answer to this question. And I wanted to finish my short introduction of Mark and his thesis with something which is also typical for his kind of humor. Usually there is not much you can laugh about in a math thesis, and there was something in his acknowledgements where I had to laugh out loudly. He has the usual acknowledgements for a couple of people at the beginning, and then he is also thanking his pet bunny who gave him much needed help when he needed a break from writing his thesis. And then he finishes his acknowledgements by saying, "I tried to employ him as a proofreader, but he preferred to simply eat my thesis instead of reading it." Found that pretty funny. So congratulations, Mark, on your fine mathematical work, and all the best for your future.
Great, thank you, Peter, and congratulations to Mark. And I'll just add in one of the main, for the PhDs, one thing really missing here, John and Christian talked about the choreography with handing out degrees, but we are missing out on the hooding ceremony today, where the advisors actually put these hoods on their students. So I hope you'll all be able to come back when we're able to do a real ceremony so you can do that. So lastly, we've had a request for the purposes of the video that we just take a moment, and if we could ask the graduates to keep their video on or turn their video on if it's not on, and ask everybody else to turn their video off so that we get like a screenshot. So if everyone could just do that right now. Okay, great. I think we can kind of wave. I think we've got everybody then. All right, if you want to turn your videos back on now, I think we've got our visual. And I think I believe that is the end of our official program, unless, John, do you have anything else to add?
Thanks so much, Julie. I appreciate everything you did to make this go smoothly, and thanks for all the graduates for all the wonderful work you did in getting your degrees, and to the advisors and to all members of the faculty and parents and everyone else. Thank you for joining us on this occasion, and we'll sign off and stay safe, etc., etc. And good luck in your future endeavors.